Chapter 6, Wireless Networking, Part 2. In this second half of our lecture this week, we're going to look at actually how to implement a wireless LAN. And we're going to look at some of the key points. There are some gotchas, and we're going to look at things to avoid. There's some pitfalls that can certainly come and get us if we're not careful. Now let's look at a small wireless LAN, like home use, right? Very common for small networks. You're only going to have a single access point, a single AP. If you have cable internet, very often that access point is built into your quote-unquote cable modem, right? It's there, it's part of it. I can certainly add additional ones. I might shut that one off and make a more powerful one. But for all my wireless devices in my house, that is my internet gateway. So I'm going to have something that looks a lot like this. Here's my internet connection coming in, my cable or DSL modem, and then here's my AP. And simply all my devices connect to this one thing. Now, things that can get me on here, dead spots, right? We talked in the first half about how this radio signal bounces and attenuates and diffuses and all that. Well, I'm going to have dead spots. So I may have to add on to this. I may have to make a bit more robust network, possibly in the form of repeaters scattered throughout my environment. For a more enterprise class wireless network, even small businesses all the way up to big mega corporations, implementing wireless requires more thought process, right? It's not an accidental thing. You're going to have more than one access point. Even in a small office, you're going to have more than one access point. And where they go has to be very deliberate. So the very first step is probably going to be a site survey. This is where an IT consultant, or you as a network administrator, whatever, goes through and looks at your environment. You're going to be looking at things that can block your signal. Wireless communication, for example, goes actually quite well horizontally, but not quite so well vertically. If you've got a multi-story building, and let's say your floors are separated by steel reinforced concrete, oh, that's going to be a barrier to wireless right there. So you need to start thinking, okay, where are we going to put the access points? How do we set them up in such a way to allow for optimal roaming? That thing we talked about where we walked around and you could switch from one AP to another seamlessly. You can have some tools with you. You may set up access points just as test and then walk around with your laptop with some of your network analyzers, more on those to come, and just get a feel for what that signal's doing. I may consider setting up what's known as a wireless bridge. I need an access point where I can have no cabling going to it. Well, one access point can act as a bridge to another, bridging this gap right here. Still, though, that signal has to make it across. So it's all about signal strength and availability. After your site survey, you should know, well, have a pretty good idea anyway, of how many access points you're going to need and where they're going to go. Now you start talking about your overall design. You're going to be part of the same extended service set. So how do we wire this in? Make sure I have network connectivity, cables that go to where my APs go, or connectivity via wireless bridge. I need to share an SSID, that system identifier. What do I want my company's SSID to be? In a way, it's a form of advertising. So you need to think about that. Do I even want to broadcast it at all? It's not required. You have to have an SSID, but I don't have to broadcast it. So these are all things to consider. How am I going to integrate my wireless network into my wired network? How am I going to manage those access points? There's all kinds of products out there, some cloud-based, some server room-based, that allow you to set up the roaming and set up security. What kind of security are you going to be using? That's a huge consideration. Once you've made these decisions, now you're ready to actually start configuring your devices. And this is after your AP has been deployed, tested, and here we go. How do I connect my individual devices? Well, it depends on the device. I mean, an iPhone connects differently than an Android device, than it does a Windows laptop versus a Apple laptop. Whatever. You're going to need the SSID. You're going to need some type of authentication, some type of password to get you in there. Possibly even certificates. There's all kinds of way we can do authentication. No matter what, though, we need to have some kind of security in place. The 802.11 standard by itself does not specify security. It is completely open, wide open. Right? The only thing you actually need is the SSID. When wireless first came out, we kind of did it this way. It's scary, but that's what happened quite a bit. The security was so hard to set up at the time that people just turned them on, left them wide open. Well, as we'll see here in a few minutes, there's some real threats that present themselves to that, including some legal ones and some liability ones. So security is something that we definitely need to have in place. You're going to need to be able to authenticate. What does authentication mean? It means proving who you are, who you say you are. Or in this case, proving your device proving who it says it is to the access point. Now I've got another few other tools I can use. We're probably going to be using some form of encryption, and that just makes sense. We don't want to be blasting our wireless out there wide open. In some cases, you don't have a choice. You go to McDonald's or Kohl's or whatever, and those are wide open networks, so you don't need a password or anything to authenticate. Nothing's encrypted. It's just wide open. For business, for home use, I don't want someone sniffing my communications. I could do something called MAC filtering. Most APs have this ability. And what it does is I give it a list of MAC addresses. And these might be the MAC addresses of all my devices. And I'll tell the AP, do not let any device connect to this wireless network unless it has one of those MAC addresses. Sounds great. And it can have its uses, but MACs can be easily spoofed. So MAC filtering by itself, not quite so hot. None of these are a reinforced steel door that'll protect your environment. Your wireless environment is insecure by definition because you're broadcasting it via radio. And that just goes to whoever can pick it up. Security, though, is like an onion. It has layers. So I can add a layer of authentication. I can add a layer of encryption. I might choose to add a layer of something like MAC filtering. And it's the combination of these layers that helps give me some type of security. So there's been a few encryption standards for wireless for a while now. The two common ones you're going to see nowadays are called WPA, or more specifically WPA2. It stands for Wi-Fi Protected Access. Now there was an earlier one back in when wireless first came out. It was something called the WEP, W-E-P, Wired Equivalency Privacy. Wired Equivalency Privacy. And it was better than being just in the air, but it never changed the encryption key. So someone sniffing that communication over time could figure out what the encryption mechanism is and decrypt it. So WEP wasn't very secure. It was replaced with WPA, or WPA1, if you will. And it was far more secure because it actually generated a new key for every transmission. Okay, that's better. Unfortunately, it didn't take that too long to really get, hacked. Our current method now is WPA2. Same idea. It uses a new key every transmission, but it uses a much, much stronger encryption protocol. It's a type of encryption that you're just really not going to be able to brute force it. It's going to change. Your key's going to change by the time you have the opportunity to crack that very hard encryption. WPA2, really common at home, right? There's also something called WPA Enterprise. That's for, well, guess what? Using it in enterprise setups in the workplace. Same idea, it's how it's managed. At home, I've only got a single access point, probably. Well, in the workplace, I've got many. How do I control that? How do I authenticate my users? How do I authenticate my equipment? Very likely, I have like a Windows Active Directory domain out there where users put in username and passwords and that kind of thing. I need some way of connecting to that, to linking to that. Well, WPA Enterprise allows you to do that. It makes use of something called the Radius server, which is really just it's an authentication proxy, if you will, that allows me to use these encryption protocols in an enterprise setting. What's this whole thing? Why are we so worried about what's going to happen to us wirelessly? Because it's radio and it's being broadcasted. And if I don't encrypt it, I don't put a password on it, anyone getting close within the receive range of my radio signal can jump right on my network. There's actually something called that. There's an action about that called war driving. And this is where people drive around with their laptop, with their Wi-Fi turned on, looking for unsecured wireless networks. That's pretty much all that it is, literally driving around trying to find it. This isn't as common as it used to be, because now access points, especially the home use ones, ship with encryption and security already turned on. It used to ship with it turned off, and people just never bothered to turn it on. Now it's shipped with it turned on, and well, most people don't bother to shut it off. So that makes for a more secure environment. However, it's still a practice of going out trying to find it. Once these hackers find an unsecured place, they need to mark it. That's called war chalking. And they actually have their own little hieroglyphic language that they can communicate with using this. They'll mark it on the sidewalk or on a wall outside of the area that says, "Hey everyone, if you know what you're looking for, here is an unsecured network. Have at it." Why don't we want people on our networks? Well, for one, they're total strangers. They're inside our environment, so they're one step closer to hacking our own machines, including stuff that has things like our banking information and privacy information, maybe healthcare information, that kind of thing. Also, they could use your network to do nefarious things, right? If I'm a criminal, I'm not going to perform a criminal act from my home network because web servers record IP addresses. Now I can do things like anonymizers and make it a little bit tougher. There's still a trail there somewhere. And if I did something nasty enough, law enforcement agencies, federal law enforcement agencies, have a lot of resources to put in to find out who I am. What I'm probably going to do is go war driving. I'm going to go find some house on the other side of town with an unsecured Wi-Fi, connect to that from my car, do whatever illegal activity I was doing, hacking somebody, whatever, and then leave. So when the police come pounding on a door, they're pounding on that door, not mine. We don't want people coming into our networks. Other threats out there we have to look out for. And these aren't so much hacking attacks, but what about a rogue AP? What if I want to record usernames and passwords? And some business, let's say some doctor's office, makes Wi-Fi available for people. But it makes it in such a way that you have to log in. Maybe it's something someone has to put in their username and password. Maybe it's next to a company, whatever. What I might do is set up a rogue AP. It's called an evil twin, and give it the same SSID or one very, very similar to the one that I'm trying to imitate. So when people see it, they go, "Oh, there it is. There's the Acme Incorporated access point. Username, password. Sorry, network is down today," is what they'll get for a message. And now I've got their username and password, which I can use to log into the real environment and do nefarious things. WPA attacks. Trying to crack into, to break the encryption. Trying to go in and figure out what the keys are. This isn't easy to do because WPA changes so quickly, but it can be done, especially WPA1. It all comes down to the same thing, that no wireless network is secure. You want security, you're not going to use wireless. So how do I test this stuff? What about when I'm doing my site survey and I'm trying to figure out where I have signal, no signal? How do I do that? Well, you do it through a bunch of different tools. Now, obviously, this is Captain Obvious, my tools I use for wired networks don't work for wireless, right? A TDR, OTDR, that type of stuff, useless in a wireless environment. Really, my tools are going to be software. Now, yes, I can buy hardware Wi-Fi analyzers, totally. But these are just little computers that are running the software. Conversely, I can go out and buy the software and install it on a laptop. And this happens quite a bit. So you're going to have things like spectrum analyzers and Wi-Fi analyzers that their whole function is to keep track of wireless signals. I'm going to set up an AP, let's say in an office, I'm testing it, and I think this is a good place for it, so I set it up in some corner, turn it on. I'm going to grab my laptop with my Wi-Fi analyzer and walk around that entire office space. I'm going to see, it's going to draw a picture of where I have strong signal, where I don't. I'll be able to map out blind spots, figure out where to put things, maybe where I need boosters or additional APs or whatnot. There's a lot of different tools out there, and most of them share some common features, such as measuring signal strength, attenuation, signal loss. Association, right? Tells you which AP are you associated to. If you're in a multi-AP environment, it's really, and you're roaming around, it's really handy to know which one you're attached to. Troubleshooting. The APs fail sometimes. They go bad. Sometimes they go intermittently bad. I need my network tools, my Wi-Fi analyzers to figure out which one it is and specifically what's going on with it. What kind of problems can I encounter while I'm designing these environments or implementing these environments? And these are common, but you'd be surprised how often they come up. SSID mismatch. You have a customer that says, I'm trying to join my network, and I just won't join. And it turns out that they're typing in the wrong SSID. Maybe I'm not broadcasting it as a security measure, and I'm making the users type it in, and they don't know how to spell it. You have to use some common sense when you're picking your SSIDs. You don't want necessarily to have them give away too much information, like the model of your access point. Here's my AeroLink 1000 AP, which sometimes the SSID is that name. Because if you didn't change that, there's a very good chance you didn't change the default password. And your hackers, your war drivers, will see that, Google that piece of equipment, and figure out what its default password is. It's just one of those things that you just don't want to give away too much information. Maybe your users are using the incorrect encryption protocol. Maybe they're trying to connect using WEP or WPA, and yours is a WPA2 environment. It's not going to work. Wrong frequencies or overlapping frequencies. The 2.4 gigahertz channel has 11, or frequency range has 11 channels. Some of those overlap with each other, right? So I can get frequency interference, noise on my wireless network. And then just obvious things like not putting the access point in the right place. If it's a unidirectional antenna, not pointing it in the right direction, that can totally happen. Maybe firmware problems. Access points are really just little nodes in your network. They're little computers. They truly are. They have firmware. They have an operating system. Like every other piece of firmware, it must be updated from time to time. Sometimes these updates don't go. Sometimes they fail. Sometimes they brick the device. So these are all concerns that you need to be looking at while you're implementing wireless, especially in enterprise, and for managing it. And that concludes our second lecture for this week's discussion on wireless networks. As always, if you have any questions, please feel free to contact me, and I'll see you next week.